In section 2.4, you're going to learn about the empirical rule, which is also known as the 68, 95, 99.7 rule. So what does the empirical rule tell us? It tells us basically that in any normal distribution, the data falls very predictably. So what I mean by that is we always have the mean right in the center. In this case, it's showing a z-score. So a z-score of 0 is the mean. And if we were to move one standard deviation above the mean to this line right here, and one standard deviation below the mean to that line on the left. Okay, we're carving out this center peak right here. And in any normal distribution, that center peak, one standard deviation above to one standard deviation below, is going to hold about 68% of all the data. If we move out a second standard deviation, so now we're two standard deviations above, two standard deviations below, okay, and we're cutting out an even wider part of that peak, okay, that section is going to hold 95% of all the values in this distribution. And then lastly, if we go out 3 standard deviations above and below to these two lines out here, okay, now we're cutting out almost all of the curve. It's leaving very little outside this big green box. So 99.7% of all values in this distribution are between 3 standard deviations above and 3 standard deviations below the mean. So let's apply the empirical rule to the histogram that we saw in the last section, showing the ITBS vocabulary score results from students in Gary, Indiana. So our histogram is down there. We see it's approximately normal, bell-shaped, unimodal. It had a mean of 6.84 and a standard deviation of 1.55, and we can use that to draw the distribution using the empirical rule. That's what this is showing up here in the top left. We can see that the mean is right in the middle, 6.84. Now all these numbers around the mean are 1, 2, and 3 standard deviations from that center. So what I mean by that is if we took that mean of 6.84 and we added 1.55, that gives us that value 8.39. If we subtracted 1.5 instead of adding it, we'd be at 5.29. Okay, if we went out 2 standard deviations from the mean, so now we're doing that 6.84 again, plus 2 times 1.55, we're adding that twice. That's how we get this number, and this number if we subtract it, etc. Now, the question that's asking is how unusual is it for a Gary, Indiana 7th grader to get an ITBS vocabulary score less than 3.74? So when we look at this, all right, we should note that 3.74 is exactly 2 standard deviations below the mean. Now, from the empirical rule, that allows us to match it up with a number. Okay, it's a 68, 95, 99.7 rule. This is 2 standard deviations from the mean. So it's going to that second one, not the 68, but the 95. Right? Now we know that this value is on the border of the center section holding 95% of the data. So from here to here, about 95% of all students fall into that section. But that's not the section we want. We want this yellow part over here. Okay, and the nice thing about this curve is it's perfectly symmetric. So if we know that there's 95% in the middle here, we know that there's 5% left over outside of that middle. And that 5% is going to be split evenly, right in half, where 2.5% is on that left side, 2.5% is on that right side. So from that empirical rule, we can estimate about 2.5% of students score 3.74 or less on this test. All right, let's try a few examples. What proportion of ITBS vocabulary scores are greater than 8.39? So to start, we have a curve down here on the bottom. We see 8.39, and note that that is exactly 1 standard deviation above the mean. Now that puts it on the mark or on the border of that 68% that's in the center, between 1 standard deviation above and 1 standard deviation below the mean. But we don't want the center here. We want what's outside of it, more specifically, outside on the right. All of these problems come back to the fact that this curve is symmetric. If there's 68% in the middle, there's 100 minus 68 equals 32% outside of that, because the curve totals 1 or 100%. And that 32% is going to be split equally on both sides, with 16% on the left and 16% on the right. So our answer to this problem is about 16% of students score above an 8.39. What proportion of these scores are less than 2.19? We see 2.19 down here. That's 3 standard deviations below the mean, putting it on the border of this 99.7%. So that's right on the edge of almost all of our data being in between that third standard deviation above and below the mean. And we're looking for this tiny sliver that's out here. Again, a symmetric curve. We're looking for the leftover, which ends up being 0.3%. And then that gets cut in half, with half on the left and half on the right. So there's about 0.15% of students scoring below a 2.19. And for a trickier one, what proportion of ITBS vocab scores are between 5.29 and 9.94? Now, everything about this curve is symmetric. So the issue that we're going to run into in this one is that the 5.29 is 1 standard deviation below the mean, but the 9.94 is 2 standard deviations above the mean. So they're not matching up on that same number. So instead, we're going to split both of these right in half. Okay, so let's do the left half first. So we're going to try to find this little sliver right here. Okay, only that left little sliver. So that 5.29, 1 standard deviation below the mean, is on the edge of this 68, but we're not going all the way over to the 8.39. We're just going halfway. And just like the rest of this curve, we can split this right in half, put half on the right, half on the left. Okay, so in that red shaded section there, it's getting half of that 68% because we're only going halfway between that 5.29 and that 8.39. And then we'll do the same exact thing for the 9.94. That's 2 standard deviations above the mean, which puts it on the border of that 95% if we went from here all the way over here. Okay, but again, we're just going to stop halfway. Okay, which means we're going to take half of 95%, which is 47.5%. So our answer for this one is going to be these two values added together. About 81.5% of students score between a 5.29 and 9.94. We can also use these empirical rule percentages to work backwards. So if it asks us, what's the 84th percentile? Right, so now it's giving us a percentile, it's asking for us for a score, right? 84%, that's bigger than half, 50% would be half, okay? So we know it's bigger than this line right here, right? There's going to be 50% to the left of this blue line, all right? And all these other ones are split up, okay? So for example, that 68%, we've now cut that in half with that blue line. There's half of it left over on this side. And conveniently, if we add these together, we'll see that totals 84%. So we know we're at this mark right here, right? That's the percentile where 84% of the data in this distribution is below it. And the cutoff for that score is 8.39. Same idea for this one, but we're going to solve it a little differently. This time it's asking us, what's the 97.5th percentile? Now, we know there's 95% within 2 standard deviations, 99.7% within 3 standard deviations. Right, so let's take a look at this one. Okay, so 95% is within this range. Okay, now a percentile is measuring everything beneath it, okay, not just the center. Right, here we're looking at just the center, but there's this other part over here that we're not counting right now. That's also included when we start talking about percentiles. So if we were to add that in, okay, there's 95% in the middle. That leaves 5% on the outsides, and that's going to get split up equally. 2.5% over here, 2.5% over here. Okay, and now we can see where that 97.5% comes from. It's coming from this tail on the left, added into that middle section, 2 standard deviations above and below the mean. Right? That means that our answer to this question, the cutoff for the 97.5th percentile, is that 9.94, which is 2 standard deviations above the mean.